Hello, my name is Chris Knight, and I'm going to be demonstrating the second extra credit problem for ENGR 267, Engineering Programming at OIT for Dr. Mateo Aboy and James Eastham. In this probability and simulation problem, I have two computers that share a single printer, and apparently during a 1 hour period, at any moment, either one of the printers could send a single print job to the printer, and each one of the print jobs can only last 20 minutes, and if the printer is busy, then a collision occurs and the print job sent second goes to a print queue and waits there until the printer is no longer busy, in which case the print queue sends the print job to the printer. I am supposed to simulate and calculate the probability of a collision and the mean waiting time. I'm not exactly sure what mean waiting time, but I'm assuming that it's the waiting time for a print job to be sent. And then I'm supposed to calculate the waiting time in the situation that there is a collision, and I'm assuming that is the time in the queue. So here's the script. And the script is kind of long, but an awful lot of this script here is actually about displaying information to me in the window as it's going. It's all inside of one large for loop. And well, let's start here at the top. My variables are mostly all within structures that I defined. For each one of the computers, computer 1 and computer 2, I've created a structure, and in that structure I have the name of the computer, and if the computer has sent the job, what time the job was done at, if the job is finished, if there was a collision, and how much time it waited for that job to print. Then I've created an array of those two structures. I've created an anonymous function here for deciding whether or not to send a print job. I'm using the randi function in MATLAB, which outputs an integer, and I've selected either 1 or a 0, and in this case a 0 is the print job is not being sent, and 1 is it is being sent. So as the loop will cycle through every minute, then the computer calls this function and determines whether or not to send a print job. And within this entire script here, I have a lot of spots where I have debug output, which is in verbose output, where I'm just outputting information to the screen in order to follow what's going on in the printer at any given moment in time. And it has basic information that's being output when it's all said and done, and it has where did I put the, oh, here's where the statistics are being calculated here using the basic formula for probability, where you're dividing the number of successful events by the number of events here that are happening. And let's run this and show what it works. Okay, here's the flags actually. I have when it's 0, then when it hits that, there's an if statement up here. So if this flag is set, then it will show debug output. And the flag is right here, D. So if I change this to a 1, then when the script hits that point right there, it'll print the debug output. So first we're going to run it here with all these set at 0 and just see what it does. So our output with 100 tests run. Now that is actually something that can be set within the program. The number of experiments to run. This is arbitrarily set at 100. I could set this at 1,000, 1, whatever. And that's the number of times this entire simulation is run to see what the probability ends up being over a larger number of experiments. So with 100 test runs, the probability that a print job will collide was found to be 100%. And the mean time that the print job waited before being sent to the printer was found to be 12.62 minutes. and the wait time for a print job in the queue was found to be 19.22 minutes. So that's what's actually happening in the script. So we can change this to a 1, and then we're going to get a little bit more verbose output by our script. And this is going to happen 100 times. Let's take a quick peek at what we're doing. So at some point here, let's see if it started at the top. Oh, no, we've lost it. All right, let's do a fewer number of tests. Okay. So computer 2 has sent its print job at time equals 2, and computer 1 has sent its print job at time equals 3. And I'm simulating time in here instead of actually waiting an entire minute. We have this for loop right here, which is our clock. And it runs through this for loop, and it increments up every minute. So I could have done this for every second, but it just wasn't clear exactly what the requirement of the specification was. So I just arbitrarily decided to test it every minute, or run it every minute. So computer 2 has finished its print job at time equals 22. The print job has sent its print job at time equals 23. So this whole little, and then here's our data here. So all of this represents one running of it. All of this represents a second running of it, so that you can see what happens during each time through it. And it's a little bit different. In this time through it, the computer has sent it after 3 minutes. After this, and the computer 2 has sent its print job after 4 minutes. And then it shows you how much time that this is waiting. Here we're saying that it went out at 2 minutes, and this one went out at 6 minutes. Here 4, 5. So there's variability here, 2 and 2, 4 and 5. This is all randomly set by this anonymous function up here, which is deciding yes or no to send the print job when a particular time has reached. And that is happening in this loop right here, where it is saying if it hasn't been sent, this is looking at the array C at the structure C, little c, and that is set by this for loop here, either structure 1 or structure 2. That's back up here at this array C here, which is an array of C1 and C2. And so if it hasn't been sent, then it runs the function and it chooses to send it. And it's sending or setting the sent flag of this array, or structure, to whatever it chose. So if it chose to send it, or chose not to send it, it's going to be updated with that information. So next time through the loop, it's not going to actually try to send it, because it will have a 1 here if it's already been sent. Now let's say we wanted to have even more output information. We can set this debug here and get even more information about what's happening at each one of these steps. So and it's basically counting down at each time. So in the first minute, the printer is idle and the queue is empty, and then it's giving us the values of our variables that are controlling this loop. And at time equals 2, we're still at this idle state. And then all of a sudden at time equals 3, we have computer 2 is sending its print job here. We see that this variable, which is a field within the structure for C2, has been updated, and this flag for the print timer is being updated. So this PT is updating the print timer for how long that's staying inside of the printer. There's actually more data being stored in this program than is actually being used, because I had originally, well, the instructions weren't clear, period. They just weren't clear. So that's what that is, running through each one of these things. So, and then it repeats itself for the next next time through, and this happening because we chose to set it at 10. It's happening at 10. So let's get rid of some of this debug output here, and let's get rid of the verbose output here. I've created this other little flag here that I thought was kind of fun, and this is going to print us a histogram with 10 tests run. The probability, oh, you're in my way, okay. Oh, darn it. Come back. Okay. So with 10 tests run, the probability that it will collide was found to be 100%. And we're saying here a histogram created of the time waiting for it to print and the mean time waiting in the queue. This is just for fun. It wasn't specified or not. I just wanted to do it just to see what kind of distribution was being created, just for the fun of it. Okay, well, let's say we run this one more time with a larger number. Let's say we run it with, how many tests? Let's say we run it with 500 tests. And, oh, what the hell? Oh, okay. Are you running? There we go. With 500 tests run, we see a different distribution, and that shows a little bit differently. But we still have a collision. It's going to happen inevitably. I've run this with 10,000, and it still has a collision. I tried to run it with 1,000,000, but it kept crashing MATLAB. So, anyways, that concludes my demonstration. Thank you.